When we do integration, there are the various methods, and one of the important method is integration by parts. It is also known as integration by product rule or integration by multiplication rule. Various names are there, but the popularly known as integration by parts. In today's video, I am going to teach you how to do integration by parts. In product rule or by integration by parts, there are the two functions. One is the u, another is the v. So there are the two functions. U is function of, suppose say, f of x, and v is the another function, let us say g of x. So there are the two functions are given and both the functions are multiplied together. So how to do integration of when the two functions are multiplied together is nothing but called integration by parts. Integration by parts, also called product rule. And now it is u dot v, that is the dot stand for multiplication, and with respect to x, because u is the function of x, v is the function of x, therefore here I have written with respect to x. Now integration of u dot v with respect to x, there is the one formula. What is the formula? U integration of v dx minus integration of box here. Here is the box. Now what is there inside the box? There is a du by dx and integration of v dx. Whatever the results comes inside the box, we have to do the integration of that part once again. So this is the basic formula of product rule. And here is whenever we do the product rule, the important is that how to select u and how to select v. If it is written first, it is not u. If it is written second, it is not u. We have to logically select u and v. So how to select u and v? So that rule is called LIATE rule. So what is LIATE rule? Let us see. While doing integration by parts, we use LIATE concept, LIATE rule. Now, according to LIATE rule, what L stand for, what I stand for, why A stand for, T stand for, and E stand for. Here, L stand for logarithmic function, I stands for inverse trigonometric function, A stands for algebraic function, and T stand for trigonometric functions, and E stand for exponential function. So whenever we do integration by parts, we should follow strictly LIATE rule so that the problem will get simplified and we are not confused what is the first function and what is the second function, what is the value of u and what is the value of v. So we are not confused. Therefore, you always remember LIATE rule while doing integration by parts. First of all, let us understand how to select u and v. Example, suppose we have the x into sin x with respect to x. There are the two functions. First is the x, second is the sin x. So if sin x is written first or x is written first, that doesn't become u. So u and v are selected only on basis of LIATE rule. Who is written first? Always not u. Or who is written later, that is not u, not v. So how to select u and v? We can select u and v by using LIATE rule. For example, in this question, x is here, so x stands for algebra. So here is the x. So here you write down x here. Below the a, write down x because x stands for algebra. And sin x comes under trigonometry. So below t you write down sin x. Now from left to right, who is written first? X is written first. So who is written first now? That becomes u, and who is written later? That becomes a v. That is a sin x becomes v. This way we can select u and v. In this example, x into sin inverse x with respect to x. So the x is algebra. So below a, write down x here. And sin inverse x comes under inverse trigonometry, that is I. So here is a sin inverse x. You see that x was written first. So can we call it u? No, we cannot call it u, because according to LIATE rule, sin inverse x is written first, and from left to right, sin inverse x is written first. After that, x is written. Therefore, who is written first becomes u. So u is nothing but sin inverse x, and v nothing but x. So in this question, u equals to sin inverse x and v equals to x. Integration by parts, the very important is that correct selection of u and v. If you don't do correct selection of u and v, then you will keep on doing integration. The integration will expand. So if you don't want to expand the integration and you want to get the result quickly, so the very important thing that you must pay attention on selection of u and v. In this example, integration of e raised to x into log x with respect to x, e raised to x is nothing but exponential function. So write here e raised to x. You see that here e raised to x is written first. Can you call it u? No, you cannot call it u. So in integration, who is written first always not becomes u, and who is written later never becomes v. You have to select u and v as per as the LIATE rule. So I have written e raised to x here in place of exponential function. Now log x, that is a L, below L write down log x. So who is written first? U is written, log x written first, therefore that is u equals to log x. An exponential function, that is e raised to x, written later, so v equals to e raised to x. So in this question, u equals to log x and v equals to e raised to x. Now after understanding how to select u and v, let us do one problem on integration. That is example number 1. Evaluate integration of x into log x with respect to x. So we have to select, first step is to select the u and v. So x comes under algebra and log x comes under L. So therefore u equals to log x and v equals to x. So integration of u into v, nothing but u into integration of v dx minus integration of this box. What is inside the box? Du by dx, integration of v dx. Whatever the result comes under this box, you have to do the integration once again. So integration of x into log x with respect to x. First of all, let us fit into the formula u. What is the u? Log x integration of v dx, that is x into dx, minus integration of box. So here is the box with respect to x. What is inside the box? Du by dx, that is differentiation of u nothing but log x with respect to x, integration of v nothing but x dx. So this is equals to log x, integration of x is x square by 2 minus integration of, here derivative of what is happening inside the box, derivative of log x, that is 1 upon x, and integration of x is x square by 2, and outside the box there is a dx. So now if any simplification possible, do it. Here x square upon x is cut down, so we get here x square dot log x upon 2 minus integration of x by 2 with respect to x. And after that again you have to continue the integration, because x by 2 is the result of the box. So x square log x upon 2 minus 1 by 2 taken outside, and integration of x is nothing but x square by 2, at the end of course plus c. So what is the final answer? X square log x. So this can be called as a I. The given question can be called as a I. So I equals to x square log x upon 2 minus x square upon 4 plus c. So this is required solution. Example 2. Evaluate integration of x into sin x with respect to x. Let us select u and v. So x comes under algebra and sin x comes under trigonometry. Therefore u equals to x and v equals to sin x. So step number 1 is over. After that, integration of x into sin x with respect to x. Let us fit into the formula. U nothing but x, integration of v nothing but sin x, minus integration of box, derivative of u, that is derivative of x with respect to x, integration of v, that is sin x, box is over, and outside the box also dx. So this is equals to x, integration of sin x is nothing but minus cos x, minus derivative of x is nothing but 1, and here is minus cos x, outside the box dx. So minus x cos x, minus into minus plus, integration of cos x with respect to x. So minus x cos x, and integration of cos x is plus sin x, plus c. This is required solution. Example 3. Find the integration of x square dot e raised to 2x with respect to x. So x square comes under algebra and e raised to 2x comes under exponential function. Therefore, u equals to x square and v equals to e raised to 2x. Now integration of u into v, that is integration of x square into e raised to 2x with respect to x. What is u? U nothing but x square. Integration of v, that is e raised to 2x with respect to x, minus integration of box. Inside the box, what is there? Du by dx, that is derivative of x square with respect to x, integration of e raised to 2x with respect to x. Let us call the given question as a I. So I equals to therefore I equals to x square, integration of e raised to 2x nothing but e raised to 2x upon 2, minus here derivative of x square is 2x, and integration of e raised to 2x nothing but e raised to 2x upon 2, box is closed with respect to x. Now these 2 and 2 get cancelled here. So this is equals to x square e raised to 2x upon 2 minus integration of x into e raised to 2x with respect to x. Now what is the problem? Problem is that after the first integration, we got here again the multiple function, that is x into e raised to 2x with respect to x. Here again we have to apply product rule. So x square e raised to 2x as it is upon 2, here we will apply the product rule. X has come, x comes under algebra, and e raised to 2x comes under exponential function. Therefore u, here the u nothing but x and v nothing but e raised to 2x. Here again we apply the product rule. So u means x as it is, integration of v, that is e raised to 2x with respect to x, minus integration of box with respect to x. Here du by dx, that is derivative of x with respect to x, integration of e raised to 2x with respect to x. After that we have to now manage the box here. So x square e raised to 2x upon 2 minus x e raised to 2 upon 2 minus integration, here derivative of x is 1 and integration of e raised to 2x nothing but e raised to 2x upon 2 with respect to x. Now what do you do? Upon 2 minus x e raised to 2x upon 2 plus integration of 1 by 2 taken outside, integration of e raised to 2x with respect to x. So x square e raised to 2x upon 2 minus x e raised to 2x upon 2 plus 1 by 2, integration of e raised to 2x is nothing but e raised to 2x upon 2 plus c. So what is final answer? Here everywhere e raised to 2x is present, therefore taking that common we get here x square by 2 minus x by 2 plus 1 upon 4 plus c. Here again we can simplify the here because 2 is the common, so that is left to you. So e raised to 2x x square upon 2 minus x upon 2 plus 1 upon 4 plus c is required answer. Example 4, integration of x into cot square x dx. Here we know that there is no direct integration of cot square x. So I equals to x. So there is no direct integration of cot square x. So cot square x has to be converted into trigonometry transformation, that is cot square x equals to cosec square x minus 1. Opening the bracket, x into cosec square x minus x, that is integration of x into cosec square x minus x with respect to x. This can be written as integration x into cosec square x with respect to x minus integration of x dx. Now the integration of x dx is nothing but x square by 2. That is quite easy. But here are the two functions. So what are the two functions? One is the x, another is the cosec square x. Here we need to apply product rule. So x is algebra. So here is a x, and cosec square x nothing but trigonometry. Therefore u equals to x and v equals to cosec square x. Therefore I equals to the first part we have to fit into product rule formula, that is u, that is x, integration of cosec square x with respect to x minus integration of box. What is inside the box? Derivative of x with respect to x, integration of cosec square x with respect to x, box is closed, and after that the integration of this part, that is x. So that is nothing but x square by 2, and so plus c will be coming here. So I equals to x, integration of cosec square x nothing but minus cot x, integration, derivative of x is 1, and here is a minus cot x with respect to x minus x square by 2 plus c. So that is equals to minus x cot x, minus into minus plus, integration of cot x with respect to x minus x square upon 2 plus c equals to minus x cot x plus integration of cot x nothing but log of modulus sin x minus x square by 2 plus c. This is the final solution. Example 5, find the integration of log x with respect to x. Here we apply one trick here because it is only one function, there are no two functions. So what do you do? Multiply by 1 into log x with respect to x, and we treat log x as a u and we treat 1 as a v, and so now we fit into the u into v formula, 1 into log x with respect to x, that is u nothing but log x, integration of 1 with respect to x minus integration derivative of log x with respect to x and integration of 1 with respect to x, box is closed here, that is equals to x log x, because integration of 1 is x, minus integration derivative of log x is 1 upon x, integration of 1 is x with respect to x, this and this get cancelled, this is equals to x log x minus integration of 1 dx, so that is equals to x log x minus x plus c. Therefore integration of log x with respect to x is taken common here, So log x minus 1 plus c. This is the solution of integration of log x. So remember, integration of log x with respect to x equals to x into log x minus 1. So you can consider it as a formula as well, as because whenever the integration of suppose log 2x is given, directly you can apply this formula. So integration of log x with respect to x equals to x into log x minus 1 plus c. Example 6. Evaluate integration of e raised to ax into sine of bx plus c with respect to x. Solution. Let us call it as a I equals to e raised to ax into sine bx plus c with respect to x. This kind of problems never ending, because derivative of e raised to x is e raised to x, derivative integration of sin x is cos x, cos and sin keep on repeating, so it is a never ending. So after some steps there is a logic. Now first of all we apply u into v formula, trigonometry part, that is sin of bx plus c, and e raised to x is nothing but exponential part, that is e raised to ax. Therefore u equals to sin of bx plus c and v equals to e raised to ax. So apply the formula I equals to, and let us call it as a equation number 1, I equals to u nothing but sin of bx plus c integration of e raised to ax with respect to x minus differentiation of u nothing but sin of bx plus c with respect to x and integration of e raised to ax with respect to x. Box is closed here. This is equals to sin bx plus c into e raised to ax upon a minus integration of sin nothing but cos bx plus c minus cos derivative of sin is cos bx plus c multiplied by b, and e raised to x upon a with respect to x. So what you get here now, e raised to ax sin bx plus c upon a minus b upon a taken outside, integration of e raised to ax dot cos of bx plus c with respect to x. You see that the again product rule has come. This type of problem never ending. So here but we have to perform product rule once again. Therefore I equals to e raised to ax sin of bx plus c upon a minus b upon a, again doing product rule. So cos bx plus c as it is, integration of e raised to ax with respect to x minus integration of box, what is the box, derivative of cos of bx plus c with respect to x, integration of e raised to ax with respect to x. Box is closed here. So I equals to e raised to ax sin of bx plus c upon a minus b upon a cos bx plus c into e raised to ax upon a minus integration, here is a minus, derivative of cos is minus, so minus sin bx plus c multiplied by b, and integration of e raised to ax is e raised to x upon a, box is closed, with respect to x. I equals to e raised to ax sine of bx plus c upon a minus, now opening this bracket, so it become minus b upon a square into e raised to ax and cos of bx plus c, minus into minus plus b upon a, and here is again b upon a, and here is integration is already there, b upon a and minus of bx plus c into e raised to ax with respect to x. This is equals to e raised to ax sine bx plus c upon a. This part is as it is, minus b upon a square into e raised to ax cos bx plus c as it is. Now opening the bracket, b square upon a square integration of e raised to ax sine of bx plus c with respect to x. But e raised to ax sine of bx plus c with respect to x is nothing but I. So we are going to put this value in this equation. Therefore, I equals to e raised to ax sine of bx plus c upon a minus b upon a square e raised to ax cos of bx plus c minus b square upon a square into I, which can be written as I plus I into b square upon a square equals to RHS part is remaining same. Now in LHS part, simplify a square upon b square divided by a square equals to a into e raised to ax sine of bx plus c upon a square minus, here I have multiplied and divided by a to create the equal denominator, b upon a square e raised to ax cos bx plus c. So I into a square plus b square upon a square equals to a into e raised to ax sine of bx plus c minus b into e raised to ax cos of bx plus c divided by a square get cancelled both sides. Therefore, I equals to a upon a square plus b square e raised to ax sine of bx plus c minus b upon a square plus b square cos of bx plus c. Now, which can be written in various ways, like this is the one of the form. It can also be written like this, e raised to ax upon a square plus b square a into sine of bx plus c minus b into cos of bx plus c plus c. So this is required solution. So in this way we have done the integration of e raised to ax sine of bx plus c. Example 7. Evaluate integration of tan inverse of root x. Solution: I equals to integration of tan inverse of root x with respect to x. In integration, always direct formula mostly not useful. Whenever the question is given, there are some simplification or some tricks are there. For example, here tan inverse of root x, it is a single function. So this cannot be directly done by using some formula. There must be some trick. Example, derivative of root x is what? 1 upon 2 root x. So what I will do now, I will multiply and divide by root x. So this can be written as a tan inverse of root x. If you do by 2 root x, then also it will be better. Okay, multiplying and dividing by 2 root x and with respect to x. Now by substitution method, let root x equals to t. So derivative of root x is what? 1 upon 2 root x equals to dt by dx implies 1 upon 2 root x dx equals to dt. Therefore, I equals to integration of tan inverse. In place of root x, write down t and 2 root x. 2 root x. So root x equals to t here and 1 upon 2 root x dx. This and this gone, and in that place what has come? dt has come. So write down dt here. So I equals to 2 is a common. So we got tan inverse t into multiplied by t with respect to t. So t into tan inverse of t with respect to t. T comes under algebra, so write here the t, and tan inverse of t, that comes under inverse trigonometry. So tan inverse t is coming first, therefore u equals to tan inverse t and v equals to t. Now applying product rule. Therefore I equals to 2 into integration of tan inverse of t into t with respect to t, integration of u into v with respect to x is nothing but u integration of v dx minus integration of box. Inside the box there is du by dx and integration of v dx and again dx. Therefore I equals to, here we are doing with respect to t, 2 as it is, and now u is nothing but tan inverse t into integration of t with respect to t minus integration of box. Inside the box, derivative of u, that is differentiation of tan inverse t with respect to t, and integration of v, that is, and here is a dt. So I equals to 2 into tan inverse t, integration of t is t square by 2 minus derivative of tan inverse t is 1 upon 1 plus t square, and here is the integration of t is the t square by 2 again with respect to t equals to 2 upon 2 and tan inverse of t into t square minus 2 upon 2 integration of t square upon 1 plus t square with respect to t. This 2 gone, this 2 gone. Here we shall be adding and subtracting 1. So this is equals to t square into tan inverse t minus integration of t square plus 1 minus 1 upon 1 plus t square with respect to t. So this is equals to t square into tan inverse of t minus, now we get the two fractions, t square plus 1 upon t square plus 1 minus 1 upon t square plus 1 with respect to t. This get cancelled. So here I can even write 1 plus t square. Just to make you understand, I have written t square plus 1. Now t square into tan inverse t minus integration of 1 minus 1 upon 1 plus t square with respect to t. This is equals to t square into tan inverse of t minus integration of 1 with respect to is t, and integration of 1 upon 1 plus t square is nothing but tan inverse of t plus c. Now the integration part is over. Now we have to put back the value of t nothing but root x. Therefore I equals to root x whole square into tan inverse of root x minus root x minus tan inverse of root x plus c. Now this is equals to x into tan inverse of root x minus root x plus tan inverse of root x plus c. Here we can do that, here tan inverse root x can be taken common. So tan inverse of root x, here in the bracket x plus 1 minus root x plus c. This is final answer. Next example, example 8. Evaluate integration of sine of log x with respect to x. Even this is a tricky problem because supportive function is not there. We have to create the supportive function. For that, first of all, write I equals to integration of sine of log x with respect to x. Now multiplying and dividing by derivative of log x. Derivative of log x is 1 upon x. So multiplying and dividing by x. So x become supportive function. Let log x equals to t. Here is a base e, implies e raised to t equals to x. Now we have log x to the base e equals to t. Differentiation of log x to the base e with respect to x equals to dt by dx. Derivative of x log x with base e equals to 1 upon x dx equals to dt. Therefore we are going to use this and we are going to use this. Therefore I equals to in place of x e raised to t sine, in place of log x is t, and 1 upon x dx gone, 1 upon x dx gone, and in that place dt will come. Now we will apply here product rule. We have to decide u and v. E raised to t is nothing but exponential function, and this becomes trigonometry part sine of t. Therefore u equals to sine of t and v equals to e raised to t. Therefore I equals to integration of sine of t multiplied by e raised to t with respect to t. Applying product rule, u nothing but sine t, integration of v, that is e raised to t with respect to t, minus integration of box with respect to t. What is inside the box? Du by dx. derivative of sin t with respect to t, integration of e raised to t with respect to t here. So I equals to sin t multiplied by e raised to t minus integration of cos t multiplied by e raised to t dt. I equals to e raised to t sin t, again applying product rule. So the cos t becomes u, integration of e raised to t minus integration of box, the derivative of cos t with respect to t, integration of e raised to t with respect to t dt. This is equals to e raised to t sin t minus cos t e raised to t plus integration here, derivative of cos t minus sin t, integration of e raised to t raised to t and dt. Therefore I equals to, here is the e raised to t can be taken common, so we have the sin t minus cos t and minus, and this much part becomes I by equation 1. So this I can be brought to the left side, e raised to t sin t minus cos t, 2i equals to e raised to t sin t minus cos t. I equals to e raised to t upon 2 sin t minus cos t. Now putting the value of t nothing but log x, so going to put this value here. So I equals to e raised to log x to the base c divided by 2 sin t, that is the sine of log x, minus cos t, that is cos of log x, plus c. Now by using logarithm property, this becomes x. You might be knowing the formula e raised to log p to the base e equals to p. This is logarithmic property. By that property, this x has come. So sine of log x to the base e minus cos of log x to the base e plus c. This is required solution. Example number 9, integrate sin x into log of cos x with respect to x. So first of all, we observe that derivative of cos x sin x is present, so it's quite easy problem. Let cos x equals to t. Whenever such problems are given, you have to see that the derivative of one part is present somewhere in the question, then the problem becomes quite easy, because derivative of cos x is sin x, so it is present. So let cos x equals to t, then minus sin x equals to dt by dx. I have done derivative here, so sin x dx equals to minus dt. Therefore I equals to here log t minus of t with respect, so minus is taken outside, integration of log t with respect to t. Now we know the formula, integration of log x with respect to x equals to x into log x minus 1 plus c. This is the formula. Therefore minus integration of log t with respect to t equals to minus, here is the t in the bracket, log t minus 1 plus c. So this becomes minus t and log t minus 1 plus c. What is the t? T nothing but cos x. So minus cos x and log of cos x minus 1 plus c. This is required solution. Here little correction. Here is a mod. By mistake I have not written. Here also mod. So what is that? Minus cos x and log of mod cos x minus 1 plus c. This is the final answer. Example 10. Integrate x cube into log x with respect to x. Quite easy problem. I equals to, here is the u equals to log x and v equals to x cube. Therefore, u, that is log x, into integration of x cube with respect to x minus derivative of log x with respect to x, integration of x cube with respect to x equals to log x into x raised to 4 upon 4 minus integration of 1 upon x into x raised to 4 upon 4 with respect to x raised to 4 log x upon 4 minus 1 upon 4 integration of x cube with respect to x equals to x raised to 4 log x upon 4 minus 1 upon 4 into x raised to 4 upon 4 plus c. This is equals to x raised to 4 log x upon 4 minus x raised to 4 upon 16 plus c is required solution. I have to stop my video here. I hope you can now solve the problems related to product rule of integration. If you have more doubts related to integration, please communicate me on my email address provided in the description box. Before saying goodbye to you, I would like to request you like, share and subscribe the channel, and meet you again with another topic. Till then, wish you good luck. All the best. Bye bye.